In our 6.12 notes, we are going to be proving triangles are congruent. There are 4 theorems to prove that triangles are congruent. The first one is the side-side-side theorem, which says all sides are the same. Side-angle-side is the second theorem, which says two sides of two triangles are the same with the angle in between them. Then we have angle-side-angle, which says two angles are congruent with a side in between them. And angle-angle-side, two angles that are next to each other and a side that is adjacent to one of those two. So let's take a look at what this would look like in a diagram. So by side, 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 this one's definitely the easiest. Let's say we have two triangles. We'll call this A, B, C, X, Y, Z. To say that these two triangles are congruent, we'd say that AB is congruent to XY, AC is congruent to XZ, and BC is congruent to YZ. So in other words, we could say that AB is congruent to XY, AC is congruent to XZ, BC is congruent to YZ, and this would prove the triangles are congruent because all three sides are the same. If we wanted to take a look at this theorem again, we would go to the next one, which is side, angle, side. This is if two sides and the angle in between the two sides are congruent to two sides and the angle in between another triangle, the triangles are congruent. So let's say again we have triangle A, B, C, and X, Y, Z. The important part is positioning the angle in between them, or in between the two sides. So I'll show you what I mean. Let's say again that for side, AB is congruent to X, Y. So this side is congruent to this side. And then we'll say that angle A is congruent to angle X. This means that the next side that needs to be congruent has to sandwich the angles. So BA is one side. That means AC has to be the other side because it'll sandwich the angle A between the two sides. And in the theorem, the word angle side is in the middle, or in between the side 1 and side 2. So you need to make sure on your diagram the same thing is happening. That's the hardest part. So if we're saying that AC is the second side, then therefore it has to be congruent to XZ. And this would prove that the two triangles are congruent because two sides are congruent and the angle in between those two sides are congruent. Now I'm going to draw another example on the back. You do not need to write this down. Please just pay attention. So again, we're going to look at triangle A, B, C, and X, Y, Z. So let's start with, so we're going to do side, angle, side again. Let's say we start with angle C. We know that angle C is congruent to angle Z. Well, if we're going to prove that these triangles are congruent by side, angle, side, we have our angle, and we need to pick the two correct sides that put this angle between them. The only side that it cannot be is BA. This side does not touch the angle at all. Therefore, it cannot be the congruent side. So we know that AC is going to be one of the congruent sides, which is congruent to XZ, and the other one has to be on the other side of the angle. So in other words, the two sides that are congruent have to touch this angle. So BC would be congruent to YC. There's a lot of ways to think about this, but you always want to go in this order, from left to right. You want to make sure that everything is going in the same order as the theorem is. Our third theorem is angle, side, angle, which is the opposite of side, angle, side. So instead of having two sides, we now have two angles with a side in between. So again, let's take a look at triangle ABC, and here is triangle XYZ. So let's say we're looking at angle B and angle C and Z. So we know that angle B is congruent to angle Y and angle C is congruent to angle Z. Well, because the theorem is angle, side, angle, with side in the middle of the two angles, the side needs to be in the middle of the two angles. So take a minute and think to yourself, which side is the only side that is between these two angles? Hopefully you thought to yourself BC and YZ. BC is in between the angle B and C. YZ is in between the angle Y and Z. Therefore, we can prove that if BC is congruent to YZ, then these triangles are congruent by angle, side, angle. Again, we'll flip over. You don't need to write this down. I just want to draw out another example for you to think about. We have ABC, X, Y, Z. Let's say we're going to do angle, side, angle. Let's say we're given the side this time instead. So let's say we're going to say that side AB is congruent to side YZ. So again, the side has to be in the middle. This side has to be in the middle of the two angles. C is the only angle that is not even remotely touching these, but B and A are. B and A make up the line, and B and A make up the two angles that we need to prove are congruent. So angle B and angle A. So we'll say that angle A is congruent to angle X, and angle B is congruent to angle Y. So then again, by angle, side, angle, use your pen or pencil and trace to make sure that everything is going in the right order. Angle, side, angle, or angle, side, angle. We've proven that these two triangles are congruent by this theorem. Our last theorem is angle, angle, side. So this one's different from the last two. There's an angle in between an angle and a side. So let's draw a picture of this. A, B, and C, X, Y, and Z. So let's start with the two angles. Let's say we know that angle C is congruent to angle Z, and angle B is congruent to angle Y. Well, our orientation this time is slightly different. We're not worrying about the thing in the middle right now. We are just worrying about where do I put the side. Right now you have two options. You just need to make sure that the side is at the end of one of the angles and not in between them. Therefore, we cannot use BC because BC is in between them. We cannot use YZ. YZ is in between the two angles. But you do actually have two options. You could say that AC is congruent to XZ because we have angle, angle, side, angle, angle, side. So that's option one. AC is congruent to XZ. But option two exists because instead of going counterclockwise, we could go the opposite direction. Let's say we didn't highlight AC and XZ. Let's say we did angle, angle, side this way. This would also, so we'd be ignoring this and we'd still say angle, angle, side. AB in this case would be congruent to XY, but it would still give us angle, angle, side, where the two angles are next to each other and the side is next to one of the angles, but not in between them. So you could also say that AB is congruent to XY. So there's a lot of ways of proving these theorems. You just need to be super careful and trace your angles and your sides with your pen and make sure that it's in the same order that the theorem states the angles and the sides.